Hi, this is our submission for the SciVis Context 2026. We built a way to explore the NASA's Climate Archive, the ECCO Ocean model, the Diamond Ocean and Atmosphere simulations, and the CMIP6 climate projections, covering ocean circulation, atmospheric wind, and decades of future climate scenarios, all from live simulation data. Instead of working with a fixed set of pre-rendered images, everything here streams live directly from the browser or from your VR. So you can pick a dataset, a variable, a depth, a moment in time, and actually explore it rather than just looking at it. Over the next few minutes, I'll walk you through the interface itself, how it is laid out, what each control does, and how it lets you dig into each of one of these datasets. Let's start with the interface.
Right here we have the dashboard. Over here you can see a couple of presets that has each of the datasets to showcase in a fast way. We have the CMIP6, the Diamond, and the two echoes. And here we have the resolutions of each of them. To our left we have our axis that allows us to see the variable that we're looking at and the color scheme. Here cold colors means colder and warm colors means warmer. And as we can see here, we have colders in the poles and warmer towards the equatorial line. Now over here in custom, we can select specifically the dataset that we want. So we have all of the datasets together, and we also have all the variables of each of the datasets. We can select our current date, our start date, our end date, and then we can just select the space that it's from 24 hours, 6 months, or 1 year, and the amount of frames that we want to load. And this will calculate how much data we need to download to create all these frames. We have the depth layers here and the ranger depth. So right here we can select how deep we want to go in specifically this simulation with the ocean depth. So let's say we want to go to 1 kilometer. We're going to fetch the data live, and then with this slider we can go deep and see exactly what's happening in the ocean. And we can just move the globe around to see. We can select a resolution from high, medium, low, and very low, and we can show land or we can completely disappear it. On our presets, for example, jet streams will show us wind speed at 10 kilometers. Global warming is the scenario where we're actually seeing the projections of the models on the CMIP6 dataset. This is the interface that we're going to see in VR now. To go to VR, you just click here, enter VR. So right here, we have the VR interface. In the middle is going to be the globe with all the values that we need are going to be right here. And then we have two control panels. On the left, we're going to have the one that selects the dataset and the variables. And on the right, we're going to have the one that selects the dates, the start and end date, and then tells us how much is this going to take to render the whole thing and how many frames we want. So we can grab the globe however we want. We can turn it, we can twist it, or we can grab it and we can put it right underneath us. And then we can just walk around it and twist it while we walk around it. So if I wanted to say watch the North Pole, I can literally walk over on top of it just to see the data in real time. With the echo dataset, we can select the resolution between high, medium, low, and very low. But here we have the depth layers, so we can choose how deep we want to go on the layers. So we're going to go from 0.5 meters to 6 kilometers. And now we have the full glove rendered right here. And this left controller, well, if we press this button right here, X, we can swap the range. So if I go down, I hold it and I lift my wrist, it'll go deeper in range. If I go lower in my wrist, it'll go higher in range. So this way we can explore the whole globe at the same time while moving or changing or adapting the surface. On this side, we have the date range. We can select the render. So we are going to say we want to see the full year phenomenon. So we're going to go from 2011 to 2012, exactly 1 year. And it's going to be 753 megabytes at this resolution. If we wanted to go higher in resolution, this is going to change. Now, if we press the button render, we're going to start fetching all of the frames at once. Right now we have only one frame. And while that loads, I can explain this button. So right here on the right side, we're going to control our time. On our left side, we're going to control our depth. So if I press the A button, I can start moving in time. So if I move from left to right, I'm going to go in from the past to the future. And we can see how the map evolves. So let's go to the surface level, which is right here, and let's go to the Americas. And over here, we can see how the temperature changes towards south the deeper we go. Right now, this render is in September 2011, and if we go closer to February, we see that we have more ice on the north side of Canada. And if we keep going in the timeline, we'll see how it changes. So that's it for the echo dataset. If we wanted to change the variable, we just go right here in the panel, and let's say we want to check the salinity. Same thing's going to happen. We're going to load everything in here, and then we can render. Let's say we want to render 20 frames, and since salinity works a little bit different than heat, we're just going to say we want to see the span of just one day. So we select 24 hours right here, and we say render. Now, if we want to see the DYAMOND dataset, right here we have the ocean data and the atmospheric data. So we're going to start by understanding what are we showing the atmospheric data. We have the air temperature, and we're going to have the same controls that we had for the other ones. And right here we have the wind speeds. So we have the zonal speed and the meridional speed, the meridional wind speed, and we would like to see this coupled together with the ocean data. So to do that, we go to the ocean data, and we created this wind patterns that calculates X, Y, and Z velocities and then maps it into the globe. So that way we can see the interaction between both the ocean with the air temperature. So let's go for a deeper layer. Let's say just 1 kilometer should be enough, or 800 meters should be enough. And now we're going to see the wind speed at surface level. So when we toggle this on, small wind patterns are going to show up. We can see in the top of the Scandinavian peninsula, there's a small vortex right here. There's air flowing through the middle of the earth. And then we have a couple vortexes in the Arctic. So this is at surface area level. If we want to go a little bit higher in altitude, we can just slide it right here. Here we have 5.5 kilometers in altitude, and it's going to change. Now, if we go higher in altitude for the wind right here, the patterns change dramatically. So it's not as affected by the geography as anymore. So you can see it flowing as more free-flowing lines, and we can see clearly two vortices. So one around the northern hemisphere, one around the southern hemisphere, and then right towards the southern point, we'll see that the wind is not as fast. But outside of the ice, we can see the wind going much, much faster. Same thing happens with here. If we go forward in time, we can also see how this changes in time. So as the ice moves forward or backwards through time, we can see how this pattern changes. Higher activity on specifically this date. We can do the same thing with all the variables to see how they react with the wind. This is just the only couple data that we are doing with our current system, but we can also see them separated one another.